Welcome to Filtration Matters, the regular podcast from BOFA International, a world leader in portable fume and dust extraction. In this series, we'll be exploring how innovations in filtration and system design are helping to improve productivity across multiple industry sectors, including in laser, 3D printing, and electronics. BOFA experts talk about how advances in extraction technology are helping to optimize manufacturing processes and product quality, while at the same time contributing to a clean, healthy working environment. Our guest today is Richard Hurd, a technical sales manager at BOFA with an international remit. In this podcast, Richard will be discussing the increasingly important role of data as industry ups its investment in automation. Specifically, we'll be talking about the contribution that digital innovation in industrial fume and dust extraction can make to laser sector productivity. Welcome, Richard. So before we talk data, perhaps you can tell us something about your role at BOFA.
Hey, Phil. Yeah, thank you very much for that. So my role at BOFA, actually, I'll start back at the beginning. About 15 years ago, I joined the company just in the production area, building some of the equipment that actually some of the models we still produce today. Quite quickly on from that, I moved into the research and development department. I helped there design some of the equipment. Since then, I moved into technical, looking at the market more widely and helping with some of the servicing requirements in the field. Then onto the product management team, again, then addressing the market even closer, looking at the future of what the market needs. And most recently, taking a role up in sales, and I'm actually positioned now as a technical sales manager, where I'm helping customers directly position systems for their applications.
Okay, thanks, Richard. So when we talk about fume and dust extraction in the laser industry, what sort of processes and applications do we mean?
BOFA actually serves a huge range of markets, but as you say there, so laser being our biggest one now, we actually divide laser up into two different segments. We do laser coding and laser engraving. We define that internally by the way the process is working. So laser coding would be somewhere where the laser is typically fixed and the product moves past it. And a good example of that would be the pharmaceutical industry, cosmetics, fast-moving consumer goods. So an obvious one would be aluminium cans or bottling lines, beer cans, things like that. And then the other sector is laser engraving, and that's where the material is placed into an enclosure and the laser moves over the top of it. But the part that BOFA is most interested in actually is then the fume generated from these processes. Whichever type of laser process you're doing and what material you're doing can generate different levels of airborne contaminants, some of which can be more harmful than others. And if they're not correctly managed, they can go into the human respiratory system and cause issues. But there's other benefits to fume extraction as well, and that's prolonging the life of the equipment, keeping the equipment clean, and also for product cleanliness. So obviously, as I mentioned earlier, fast-moving consumer goods, they're products that humans are going to consume, and we need to make sure that those environments are kept clean.
So you mentioned about why filtration technology is needed. Laser equipment must be pretty expensive. So what could happen to a laser lens, for example, if there is not effective extraction?
So if the laser area isn't kept clean, specifically say the laser lens, then we can get very fine particulate dropping onto the laser lens or finding its way to the laser lens. And then as the laser then continues to fire through, it heats that up and it can actually bake it onto the lens. You're then going to get, one, obviously lens damage, but two, you're going to have a less efficient laser mark. And that then for the customer is going to lead to more product rejection, as the mark isn't clear enough for the camera system to recognise, and it will reject that product. I'll just be clear on that. The mark I'm talking about here, sort of default talking back to the fast-moving consumer goods side of the market. This is typically a best before date that you'll see on your food, along with a batch code for traceability.
Following that theme, what sort of speeds are we talking about on, say, a canning line?
Yeah, interesting you picked that one. That's probably one of the fastest ones that we've come across so far. So the fastest one that I've personally been involved in goes up to about 95,000 cans per hour. But I have heard sort of rumours from the market of them going up to anything as much as 120, 140,000 cans per hour. So I've actually been to a couple of these sites, and when you stand next to the production line, it's a blur. It's absolutely impossible to see what's going on. And the interesting thing is, as you mentioned, lasers being very expensive, I've actually heard now that some of the camera systems that are having to be installed to keep up with the production lines are actually becoming the most expensive piece of equipment.
So perhaps now would be a good time to cover what a typical extraction system developed by BOFA looks like.
I always default back to talking about the AD Oracle IQ. It's a sort of middle of the road but flagship model that BOFA provides. It's the one that most of the sales guys will typically go into an application offering, and then they'll migrate left or right of that depending on the size of the application. But to sort of describe it, it's just over sort of waist height. The one that I'm talking about for fast-moving consumer goods, again, is a stainless steel system. It's IP56 rated as their washdown environments. And a little bit about how they actually work. The air actually on the BOFA system goes into the bottom of the extractor. And that's because BOFA has something called reverse flow. The air actually enters, as I say, at the bottom and goes directly into our pre-filter, which is BOFA's patented Deep Pleat Duo pre-filter. This is where the reverse flow comes into action. So we have two sort of forces at play once the particulate enters the filter. Where the air enters the system, it goes directly into the pre-filter, and it comes in for a fairly narrow tube, but then goes into the bottom of the pre-filter, which is a larger area. That larger area causes the velocity of the air to drop, and therefore some of the larger particulate falls out of the airstream into the base of the filter. But the remaining contaminated air continues upwards, so against gravity, that's the reverse air side of the system, through the first filter, which is the pre-filter. That takes out the larger size particulate. It then continues on. Any of the very fine particulate that got through that filter will go into the combined filter, which is the secondary filter. That contains a HEPA layer, which takes out all of the microscopic particulate, and then onto the the carbon filter, which will then remove any of the gases or smells coming from the product. Once it's done that, the air then goes through the motor and then can be ducted outside the building or returned to the workplace.
That's a lot of technology which needs to be controlled, which brings us to data. Across manufacturing, there's a lot of investment going into automation at the moment as companies look to exploit the potential of digitalization. This is being framed as Industry 4.0, in other words, the next industrial revolution. What's your take on Industry 4.0? What do you think it is?
For me, and for BOFA, it's definitely about data capture and having a lot of these, I call them machines, but units, anything in the factory that can talking together. So if I sort of go back to a fast-moving consumer goods line, take yogurt pots, for example, I've had first-hand experience of one of these production lines. The plastic roll would come in at the back. That would be blow molded into the casing for the yogurt pot. That would then have to be filled up with the yogurt, potentially extra flavors added. The label then being added to the top, that being laser marked, that laser mark being checked. Off it goes down for multi-pack packaging, then final packaging, then shipped out. I'm sure there's many more processes in the middle of that, but all of those processes need to be controlled and monitored. And if one of them isn't perfect, then the production line could stop or slow down. And obviously some of these companies that are producing, hundreds of thousands, millions of these products per year, efficiency is key. BOFA's being one of the systems on there that is critical to production. If our filters are blocked, then the production line has to stop and the laser can't continue. So that's downtime. And that, for most of our big customers, that's their biggest enemy. So BOFA wants to do everything it can with its product offering to remove that unwanted downtime. And one of the best ways we can do that is by offering a system that can almost predict when its filters are going to block. So if we can collect data and provide that data to our customers, they can then begin to schedule filter changes in aligned with their maintenance schedules. So they're doing predicted downtime, or scheduled downtime, I should say, not unpredicted downtime.
So it sounds like you're describing a smart factory. How well is BOFA positioned to support this culture of data and innovation?
I suppose to answer that question, I could probably rewind a little bit there and sort of talk about how the products evolved over the years. Back when I started at the company, the systems were pretty basic. We just had a red light that came on to say your filters are blocked. It didn't tell you which one, didn't tell you anything about the system. We just had a red light that lit up, and then the customer knew they had to do something. Over the years, as technologies advanced, we've added more features to the product. From that single red light, we then went to a sort of traffic light system. So green for good, amber for my filters are nearly blocked, and then red for my filters are fully blocked and this machine needs some attention. We then went from there to auto flow systems, where the motor is actually regulating the airflow. And depending on how blocked the filters are, the system would monitor that and constantly maintain a set airflow. But really where this sort of technology has really helped our customers now is with IQ, and I'll go on to talk about IQ2 in a second, but IQ that we've been supplying now since 2012 was the first bit of sort of data capture that we started doing in our systems. One of the biggest features that system offered was independent filter monitoring. So we actually then were able to tell our customers exactly which filter was blocked, so the pre or the combined filter, and we'd actually display on the screen how blocked each filter was. But as I said, we were doing data capture of that system as well, and that was retrievable by a USB download. So we were capturing pre-filter blockage, combined filter blockage, airflow, set point customer, adjustments, temperatures, motor percentage output, things like that. If the customer took regular downloads of that system, they would actually begin to see trends in their filter usage. But that still is a manual process. And obviously, as we talk about Industry 4.0, we're trying to automate our factories and get to a smart factory kind of situation.
So how different is IQ2 from the original IQ operating system?
So in terms of the actual physical unit, the systems look quite similar, with the biggest exception being the color touchscreen on the front. So the original system had a black and white display, but the new system features a large color touchscreen display, as I say there, and that's the biggest physical difference to the system as you approach it. But really, the intelligence is within the system. So we're now capturing much more data than before. We're not only monitoring filter blockage percentages, we're actually monitoring pressure readings throughout the system. We've got additional sensors in there. We're taking a huge amount of data and collecting it together with a larger memory. So we actually have now about 1 year's worth of memory that can be stored at any one time in the IQ2 system, whereas previously that was only 3 months. So one of the most interesting things about the IQ2 is that it's Industry 4.0 aligned. And what that means is, although the system is collecting data internally, it will also be able to share it externally in a two-way communication format. So our customers will actually now be able to request information directly from the BOFA system. We will then gather that information together for them and send it out to their computer system or cloud, wherever they may need that information to be stored.
This sounds like fantastic technology, but what's the benefit to laser operators of creating such a data-driven filtration environment?
So the big one for me that sticks out, again, is a little bit like what I talked about earlier, where we are able to now give our customers the ability to plan their maintenance schedules exactly. So, if a customer was today running their filter until it blocked, that may happen today, tomorrow, in a week's time, but they wouldn't know exactly when it's going to happen. With that, they would then have a production stop. They would then have to go and collect the filter, install it, and then start the line up again. With the data that we'd be able to provide now to the customer with the IQ2, they would be able to monitor their filter usage through the data collection and then actually schedule in filter changes just before they become blocked. So an example of that would be if the filter was going to block in 2 weeks' time, but they knew they had a maintenance schedule in 1 week's time, it would make sense for that customer to see that from the data and then change the filter ahead of time. And that 1 week's filter life there that they've effectively come short on is insignificant when we talk about unexpected line stops. What I am excited to see is how our customers are going to use this feature on the IQ2 and the data trends that they'll be able to pull out and all the useful information it's going to provide for them for keeping their factories optimized and as efficient as possible.
Our guest today has been Richard Hurd, Thank you very much for your expert insight, and hope to talk to you again shortly.
Thank you, Philip.
Thanks for listening. If you want to find out more about BOFA and the benefits of filtration and fume extraction, visit bofainternational.com, where you'll find lots of sector-specific information. You can also catch up on all our podcast content by visiting bofainternational.com/podcast.